Okay, let's start section 10.3. And our objectives here are basically all about intercepts. So let me give the formal definition, or I guess an informal one first. So given an equation in two variables. So any equation in two variables we can graph, and not all of them are graphs of straight lines. So in this case we're going to just consider x, y. So let's just recall some things about this. So the graph of the equation, so that's the visual aspect, is the set of all points. Remember, a point has two directions or two coordinates, an x and y, of all points x, y, where the values of x and y make the equation, and of course the equation now is in two variables, and we'll consider those variables x and y, true. So the y-intercept, and we'll show some visual examples of it in just a second. The y-intercept of the graph of an equation, and again, when I'm talking about equations now, I'm talking about equations in two variables, is the points where the graph crosses the y-axis. Now I'll draw a really quick little diagram over here. So suppose this is our rectangular coordinate system. So sorry, fill that in, make that this is my y-axis, and this is my x-axis. So let me graph some kind of thing. Let's just do a straight line. So that point right there, so this is the graph of a straight line in what is that, orange? And where it crosses right there, maybe I should draw another one, another straight line. Where it crosses the y-axis is the y-intercept, and it crosses at a point. So the point value is always going to have x is equal to 0, and then we're going to have a value, some real number b. So, and there can be more than one. So the y-intercept of a graph of an equation is the point or points where the graph crosses the y-axis. These points or points are given by 0b for some number b. So this is important. That's how you recognize in the mathematical symbolism. So visually, it's easy to see where a line or the graph of an equation crosses the y-intercept. That's easy. I mean, just look, you find the y-axis, and you see where it crosses. And it could cross more than once. But this is the harder part, seeing it mathematically. So as soon as you see, for example, if you know the point 0 minus 3 lies on the graph of some equation in two variables, then as soon as you see that this first value is 0, you know that this point corresponds to the visual y-intercept, and there might be more than one. Except for this class, we're just going to be dealing with one, if they exist at all. One more thing, and then I'm going to show you some examples. So we have more than just the y-intercept. We also have the x-intercept. So the x-intercept is the point or points, that's supposed to be in there, people, sorry, where the graph of an equation, and of course these equations again are in two variables, crosses the, guess what, x-axis. So again, let me draw another example of that. I have some better illustrations for you. So here is my rough sketch of an x and y axis. So I'm going to draw two different graphs. So a graph of a straight line. That point right there is going to be where the graph of this straight line crosses the x-axis. So this is the x-intercept for that particular graph. Some equations have more. We actually might find, and eventually you will, equations that look like parabolas. And they actually have two x-intercepts. That said, in general, that's what they look like. Like I said, they're easy to see visually. What do they look like mathematically? Mathematically, and this is the hard one for you, visual's easy, and it's not really hard. Mathematically, these points, point or points, have the form B0 for some number B. So if we look right here, let's just pretend this is minus 3, this point right here for this line, minus 3. Well, if it's clearly on, there's the origin right there, which is 0, 0. So this point we're just pretending it's minus 3, and the y-coordinate is going to be 0. So again, in this case, the number b would be minus 3. So let's look at some more examples of intercepts. So here's our first example. So this is just the graph of a straight line. Right down here is the point where the graph crosses the x-axis. So that's called the x-intercept. And right here, and it looks like the value here would be minus 2, 0. And here is the other point where the graph crosses the y-axis. So that's the y-intercept. And that point is going to be 0, 4, which you can see over here. So let's look at some others. Let's look at another one. So here I have another straight line. It's a line, and it's slanted, of course. And this point right here is the point where it crosses the x-axis. And it has coordinates -10, 0, as you can see right there. Down here is where it crosses the y-axis, and it has coordinates 0 is the x value, and -5, as you can see right there. And one more example, one that I wanted to talk about. Here we have what's called a parabola. And right here is the point where it crosses, one point where it crosses the x-axis, and another point where it crosses the x-axis. And the point right here where it crosses the x-axis is 0, 0. It crosses at the origin. And over here where it crosses the x-axis, the x value is 6 and the y value is 0. Well, what about the y-intercept? Well, actually, where it crosses the x-axis, it also crosses the y-axis. So in that case, the y-intercept is also 0, 0. They're the same. I'll change this just a little bit. Shift it down a little bit further, and now we have different x and y intercepts, and you can see they were automatically updated by the program. But down here I have another y-intercept that's different from the x-intercepts, and in this case the y-intercept is 0, -3. So there are some examples of different intercepts of different graphs. So what we want to do, and what we're tasked to do, is much easier. We're just going to be dealing with linear equations. So the graphs of straight lines, not parabolas, but straight lines. So, and we're going to use, literally, we're going to use the technique that I told you just to graph in general, because it works. And in other words, they want us to graph each linear equation by finding and plotting its intercepts. So we've already done this very first example once. So let's first remind us before anything else. We just discovered something. If the graph of an equation goes through the origin and here I'm going to add something linear. So we're just talking about lines now, straight lines. So if the graph of a linear equation goes through the origin, then the x-intercept and the y-intercept are the same. And by the same, I mean they are the same point. And what is that point? It's the origin, which has coordinates 0, 0. So that's going to be important. Number 2, to define a unique line, and really it's not so much as to define, but in this case they're going to be graphing. we need bare minimum at least 2 different points. And one more bit of information. Because this is really what math is about, is putting together a lot of information. That's the reasoning aspect of math, which I don't want to get lost in this class. If the y-intercept and x-intercept are not the same point, and again, we're just talking about linear equations right now, then you can graph an equation of a line, or a linear equation. So remember, we're always talking about linear equations here, by finding both points. So let's think about this and put it all together. So let's go back over and look at number 1. It says if the graph of a linear equation goes through the origin, then the x-intercept and the y-intercept are the same point. I'm going to add something else. This is the only time they are the same point. By they, I mean the intercepts. Two, in general, to graph a unique line, we need at least 2 different points. And 3, if the y-intercept and the x-intercept are not the same point, that means we get 2 different points, and that allows us to graph an equation by finding both points. What happens if they are the same point? What happens if the graph goes through the origin? So, the fourth, to graph a linear equation whose x and y-intercepts are the same, we need to find another point. And of course, by finding another point, it's a point that is not either the x or the y-intercept, because they're the same. So let's just keep all of that in mind. Those are really important concepts, and they're really not that difficult. It's actually, let me just give you visually really quick what I just said here. So again, I'm going to try my best just to freehand. The rectangular coordinate system. Good enough. So let's draw 2 different lines. One is going to be given by I've got my ruler here. Right here. So we can see that I have an x-intercept right here and a y-intercept right here. And this is my x-intercept right there. These are points, remember? They are points. Now, I don't know what the values are, but this is going to be some value of b and 0. And over here, this is going to be some value. This is going to be some point that starts with a 0 in the x and some value of c. Now on the other hand, and I don't even know how to try here, if I draw a line, good enough, I'm going to stop while I'm ahead. Now this line that I drew here, let's take note that the intercept, both x and y, is the origin. So this line here goes through the origin, which is just another way of saying it goes through 0, 0. So in order to plot it, I need to find another point. It could be a point down here, or up here, or up here. It doesn't matter. I need 2 points. Here, in this case, my y-intercept and my x-intercept give me 2 points. Here, since the line goes through the origin, it's not enough to find the x and y intercepts because they're the same. I have to find another point. And I'm telling you all this because literally that's going to come and play in the very first example they give us. And let's scoot her down and give us some more room. So here is what I told you yesterday, and we actually did this example yesterday, or whenever you last watched this video, is we're given the equation x minus y is equal to 2. And we want to plot by finding the intercepts. So we make a table of values and we do our kitty corner zeros. So this will give us 2 different points if and only if the line doesn't go through the origin. So this first point here, I'm going to find, when I find the value y here, this point that I find in my first row is going to be my, think about it, what is it going to be, my x-intercept or my y-intercept? Think about it. The first coordinate is 0. It's going to be my y-intercept. You think, oh no, I got it wrong. That's okay. Visualize it. And this next point, if they're distinct points, will be my x-intercept. So when x is equal to 0, you get your y-intercept. When y is equal to 0, you get your x-intercept. So let's do the first row. We're given that x is equal to 0, so I want to find my value of y. So 0 minus y is equal to 2. So I have minus y is equal to 2. So now I'm going to multiply both sides by minus 1. So minus 1, both sides, maintains the equality. So minus 1 times minus y gives me y. And this is equal to 2 times minus 1 is minus 2. So my value of y is minus 2. It's not the origin. So that means immediately when I find my x-intercept, I'm going to get a different point. Now we have our y value is equal So this tells me, before I go on, my y-intercept is the point. Here is going to be really important. These, we live in 2 dimensions now. These are points. They're not numbers, they're points. Our y-intercept is a point on the graph that has 0, -2. So now let's find my x-intercept. So to find my x-intercept, set y equals to 0 and solve. So it gives me x is equal to 2. And this point here, 2, 0, is my x-intercept. So let's plot those. So I have 0, -2, and 2, 0. So you're supposed to plot them using this. So on your paper, find 0, -2. So this is the y-intercept. So you just go down the y-axis until you get to -2, and you'll put a little dot right there where my cursor is pointing. I'm hoping you can see that arrow. I made it bigger, hoping that you all would be able to see it. And then my x-intercept, go along the x, y is 0, so x is, so you'd put a dot right there, and then you draw a line through them using GeoGebra, my electronic version. We will do that here. That's good. So I'm going to put a point at 0, -2, and then another point at 2, 0, and then I draw a line through them. And right there is what your line should look like. So I'm going to delete a lot of these because I'm going to be coming back to it. I can turn them off, but sometimes it's just better to delete them. Okay. So what I wanted to do is change this up just a little bit. Suppose instead of having x minus y is equal to 2, our equation was x minus y is equal to 0. They probably give you one in here, but I'm not for sure. I've not looked ahead. What am I doing? I'm using my mouse. I need to be using my stylus. It's much faster. There we go. Get rid of all this too. So x minus y is equal to 0. Now I changed the problem. This is not one of our problems. 2a was x minus y is equal to 2. So let's try to find my 2 points. So I'm going to try my y-intercept first. So I'm going to plug in 0 for x. So that gives me minus y is equal to 0. And when I multiply both sides by minus 1, I get y is equal to 0. And pow! I just discovered that my y-intercept is 0, 0. So by one of the things I said earlier, that also means my x-intercept is 0, 0. So I need to find another point. And here's what I would say. I would say choose some other whole number value, like 3. And you can make it x or y. It doesn't matter. Because we need to find 2 points. And so I chose 3. I only got 1 point that way. So I had to find another one. The only time you have to do this to find another point is if the x-intercept and the y-intercept are the same. So now I'm going to let x equal to 3. So I'm going to put my 3. Let's make this easier. Let's put my y and move it on the other side. So that gives me y, 3 is equal to the minus y becomes plus y. So I get 3. So I find 2 points, 0, 0, and 3, 3. Now 3, 3 is neither an x-intercept or y-intercept, but it is another point on the graph. And it would be about right there would be about 3, 3. And right there is my origin point. Right there is 0, 0. So we would just draw a line through those 2 points. Okay. Anyway, let's go back to what we're assigned to do. Let's go back to our worksheets. And let's do problem 2b. So 2b. So our equation in 2 variables is x minus y is equal to minus 3. And again, we make our table. It's always a good way when you're plotting lines to make your choices easy. And you make your choices easy by doing kitty corner zeros, remembering the first is my y-intercept and the second corresponds to my x-intercept. But I have to fill in what y is here. So this says let x be equal to 0. Find out the value of y. So that gives me minus y is equal to minus 3. So I can either move the y to the left to right hand side and the 3 over, or I can multiply both sides by minus 1 or divide by minus 1. Either way, it gives me y is equal to 3. So I just found a point. This point is the y-intercept. So now let's find the x-intercept. And we find the x-intercept by making y equal to 0. So that gives a value, x minus 0 is just x. X is equal to minus 3. So minus 3, 0 is my x-intercept. So let's plot those. Again, on your paper here, you're going to do the y-intercept first. So you go up and down the y-axis. There's 1, 2, and 3, and you'll put a dot right there. And for the x-intercept, it's minus 3, 0. So you go down across, there's minus 1, minus 2, minus 3, and you'll put a dot right there, and you'll draw a line between both of them. So here is my x-intercept at minus 3, 0, my y-intercept at 0, minus 3, and I'll draw a line between both of them, and that's what it should look like, more or less. So that was the graph of 2b. So let's do another one. So this was a good one. This is a good one for you to try on your own. So I would go ahead. It's 2x plus 4y is equal to 8. And there's a lot of ways you can do this one. But go ahead and start doing it. And then I will, of course, join you here in just a second when I get my stylus and everything set up. So this is problem 2C. and we're given 2x plus 4y is equal to 8. And we want to find, we're going to do the table of values, x, y. We start out with kitty corner zeros. And remember, if you put a 0 in the x, like if you have them kitty corner like I have here, the first row corresponds to the y-intercept, and the second corresponds to the x-intercept. So let's set x equal to 0. So I have 2 times 0 plus 4y is equal to 8. So 2 times 0 is 0, so that gives me 0 plus 4y is equal to 8. So that's the same as 4y is equal to 8. So I'm going to divide both sides through by 4. And the final step is going to be y is equal to 8 divided by 4, which is 2. So here I have 0, 2 is my y-intercept. Why? Because my x value is 0. Now let's find the x-intercept, and we do so by setting y equal to 0. So that's 2 times x plus 4 times 0 is equal to 8. So this gives me 2x plus 0 is equal to 8, which means 2x is equal to 8. And I'm going to divide through both sides by 2. So that's going to give me the value of x is equal to 4. So 4, 0 is my x-intercept. So you would plot them here. So 0, 2. So what you're going to do is, here you have your graph. So you're going to do your y-intercept first. So you're going to start on the y-axis and go up 1, 2, and you're going to put a dot right there. And then for your x-intercept, you're going to go start at 0 and move over 1, 2, 3, 4, and put a dot right there, and then draw a line through both of them. Or using GeoGebra, I'm going to put a point at 0, 2. It's my y-intercept. And 4, 0. It's my x-intercept. And the line that goes through both of those looks like that. I guess we need to do D, E, and F. So notice in every case right now we've been really lucky. None of our lines have gone through the origin. So this is 2D. And we're given the equation x minus 3y is equal to 0. So I do my kitty corner zeros. And again, the first row corresponds to y-intercept. Second row corresponds to x-intercept. So I set my x value is equal to 0. So that means minus 3y is equal to 0. So I'm going to divide both sides through by the coefficient of the y term, which is minus 3. Notice I'm not dividing through by 0. 0 in the numerator is fine. So this gives me y is equal to 0 divided by minus 3. Just in case you forget, 0 divided by minus 3 is the same as 0 times 1 over minus 3. At any rate, the answer is 0. And unfortunately, what did I just discover? This line goes through the origin because this corresponds to the point 0, 0. So that tells me that my x and my y-intercept are the same. So that means I have to find another point. Because remember, our goal is to graph these lines. So in this case, let's just be, you can literally choose any value you want. So let's choose a value of 5 for y. Let's make it a little bit smaller. I'm not for sure how big your little plotting goes. So let's choose a value of 2. Or let's do minus 2 for y. What the heck? So x minus 3 times minus 2 is equal to 0. So we're solving for x. So x minus 3 times minus 2 is plus 6 is equal to 0. So I'm solving for x, so I'm going to move the plus 6 over, and it becomes minus. So I found another point, minus 6 and 2, and minus 2. I want to make that minus 2 here. So we already know it goes to the origin, and you can kind of plot it this way if you want. Well, I lost my pen. You kind of just eyeball things. So it goes to the point 0, 0, and then it goes to the point minus 6 and minus 2. That's minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. And then I go down to minus 2. So just eyeballing, it's going to be about right there. And then you draw your line through it, and it goes to the origin. That's eyeballing it. So let's do it on GeoGebra. The origin and minus 6, minus 2. Take a look and see what it looks like really. So it's going to go through the origin. That's easy. Right there. Then minus 6 is right here. Minus 2 is right there. There's minus 6, minus 2. And it looks like that. Okay. Let's do E and let's do F. So I hope you're not being overwhelmed. This is really kind of fun if you think about it. Go ahead and do. This is 2E. Let's change my colors. So I'm given y is equal to 3x plus 3. So again, you all should try to do this on your own. You should be pausing this video right now and trying it. That's the best way to do it. Kitty corner zeros. First one, y-intercept. Second one, x-intercept. So the first one, I'm going to set x equal to 0. Oh, how nice that came out. So that's y is equal to 0 plus 3, which gives me y is equal to 3. So good. It's not the origin. That means when I do the other point, I'm going to get a different point. So the y-intercept is 0, 3. So when I do the x-intercept, I have to get another point by previous comments. But what I told you at the very, very beginning. So now I'm going to set y is equal to 0 and solve for x. So I'm going to move the plus 3 to the other side. So that's going to become a minus 3. If you want to add minus 3 plus 0, that's fine, but it's still just going to be minus 3. So minus 3 is equal to 3x. So I know how much 3 of something is. So to find out how much one of those somethings is, I divide it by that quantity by 3. So minus 3 divided by 3 is minus 1, and that's how much 1x is. So I get another point, minus 1, 0, which is the x-intercept. So let's see what those look like when you graph them. You should be able to graph these really fast. By the time I write this down, you should already have it graphed. So 0, 3 is my x-intercept, my y-intercept. And minus 1 and 0 is my x-intercept. And the line that goes through them looks like that. A little bit steeper than what we've been looking at, but that's what it looks like. And let's do y is equal to minus 2x minus 4. So this one is equal to, we're doing 2f minus 2x minus 4. Y is equal to minus 2x minus 4. So we're going to set x equal to 0. So it gives me y is equal to minus 2 times 0 minus 4, which is equal to y is equal to 0 minus 4. So y is equal to minus 4. That's good news. My x and y intercepts are not the same. That means it's not hard to be creative and choose another value of x or another value of y, but in this case it's kind of nice. Now we're going to set y is equal to 0. So I'm going to move the minus 4 over, and it becomes plus 4. So now I know how much minus 2 of something is. So to find out how much one of those things is, I'm going to divide that quantity, which is 4, by minus 2. So 4 divided by minus 2 is minus 2, and that gives me x. So minus 2. So the y-intercept is 0 minus 4. The x-intercept is minus 2, 0. So plot those for me, and we'll go take a look on what it looks like on the GeoGebra screen. So over here on GeoGebra, we're going to plot 0 minus 4. So that's going to be my y-intercept right there. And minus 2 and 0 is going to be my x-intercept right there. And now we draw the line through them. And that's what the equation looks like. Or sorry, that's what the graph of the equation looks like. Okay, you got to do some more. So now let's identify the type of equation. So let me just remind you of some stuff that I talked about yesterday. And you might want to get out your notes. So 1, the equation of a horizontal line so think this way, a line that's flat is given by, and I'm not going to write the whole thing, an equation that can be reduced to y is equal to c for some real number. And here I'm going to emphasize this is a constant. So this is a constant. E.g., for example, y is equal to 2. 2. The equation of a vertical line, so we're talking about lines that go straight up and down, is given by any equation that can be reduced to x is equal to b. In this case, b is also a numerical constant. I don't say real number constant, that's all you know about in this class. For example, x is equal to minus 1/2. So with that in mind, let's actually find and plot these types of equations. So my first one is the following. This is 3a. X is equal to minus 3. So that tells me this is a vertical line. And how do we find 2 points on that line? You just put minus 3 in the x, and you can put your y value anything, because the x is a constant value. So now just go on your graph there and plot minus 3 and 0 and minus 3 and 2 and see what you get, and draw a line through those 2 points. So going over to GeoGebra, we will do that. So minus 3 and 0 is right there. And minus 3 and 2 is directly above it. And our vertical line goes through, looks like that. Notice that this particular line, this vertical line at x is equal to minus 3, never intercepts the y-axis. That's no surprise, because if it did intercept the y-axis, then the first coordinate would have to be 0. But it can't be 0 because x is always minus 3. So that tells you that not every equation of a line intercepts the y-axis. It does intercept the x-axis, and of course if it does intercept the x-axis, in this case it only intercepts the x-axis at one point. So let's go back. Y is equal to 2. Just want to do some erasing here. I could have left that one. That's okay. So in this case, decrease, 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 decrease. In this case, we are given, we're doing 3b, we're doing y is equal to 2. So that means y has to be equal to 2 in our table of values. And you can put x to be anything you want. So here we have 2 points, 0, 2, and 2, 2. Now I'm going to let you all plot those. And in general, I'm not going to do, I think this is so easy, there's no reason to do anything like go into GeoGebra. So here's my y-axis, here's my x-axis. So I'm going to say that's y is equal to 1 and y is equal to 2. So that noise you just heard is just my email inbox from school. So the point 0, 2 is right here. And I'll make this 1 and 2. So this is 1 and 2. This is 1 and 2. So my point 2, 2 is right there. And my horizontal line is going to run straight away that way. And this is the graph of y is equal to 2. And the last one, and we actually did, I'm kind of proud of myself, I anticipated this yesterday, and we already did this. So we'll do this one really, really fast, and that'll be the end of this lecture. I've got 3 more I have to record before the end of the day, one of which being your class. So this is problem, I think we're on problem 3. This is 3C. Yeah. So we want to do x plus 3 is equal to 5. Notice there is no y. There's no y to be found. So all I do is I solve for x. And that gives me x is equal to, I move the plus 3 over. So that gives me x is equal to 2. So now it's really easy to find 2 points. X is a constant, so I have no choice but to put 2 in the x column. And I can put any numbers I want in the y column. So I'm going to have 2 and 0, and 2 and 2. And I will let you plot those on your own. I feel very, very confident that you can do that. So that's all for section 10.3.